I know there is a popular belief that property collector is this incredible monster that you can't really use. Well, the reason why I said it's a myth is it is really a myth. If you look at exactly how it works and how you can use, I'm pretty sure most of you are going to say, oh, is this simple? I never knew that it is going to be that simple. So, first of all, pretty much any software management application when you write, that involves a couple of things. You need to get the data, and you need to set something, and probably some monitoring and stuff like that. In vSphere, like in vSphere platform, there are certain things. The way that the vSphere platform is organized is anything that you see in your vSphere client is an entity, managed entity. So in order to get the data for any of the managed entities, you needed a way to do that. And that is, property collector is the only way that you can get the data. For setting the data, you can actually use several of the APIs that are out there. So every API call, as you know, requires setting the managed object reference. If you need to find out the managed object reference, you need to know either using property collector or search index API or views, any other stuff. Anyway, so suppose you want to ask your friend a favor. So you want him to pick up something for you. What do? You just tell him, hey, can you pick this up from this location? Which means you're telling him what you want to pick because you are asking him a favor. And if you're a nice guy, you'll give him directions too. When you are going from there, just here are the directions. Can you please get them for me? Imagine you are asking property collector a favor. When you are asking property collector a favor, what I mean is you are asking it to give you some data. And you are telling property collector, hey, the data is there. You are right here. Go from this location to that location and get me that data. That's all there is to it. Believe it or not, all you have to do is tell it what you want, tell it where to get it from. That's all it is. The end goal of this talk is to make it clear that property collector is not a monster that people made out it to be. So I just want you to understand what goes on under the hood. And if you have any questions, please feel free to interrupt me and ask me questions. You don't have to wait until the end. And all the slides are going to be made available to you. So don't have to worry about writing down or any of that stuff. Yeah. It's probably 2 weeks after the VMworld or something. I'm not really sure.
Slides for things we missed as well.
Pardon me?
Can we get slides for sessions we missed also?
Yeah, all the session slides are going to be posted online. I think.
Some of the speakers said they posted theirs up on Sunday night, but before the event, as if they're going to be refreshed afterwards.
So typically what happens is we give the slides to the VMworld committee or whatever it is, and then they bring it up here, and then they take care of recording these sessions and posting them online probably 1 or 2 weeks later. Okay, this is not an introduction to SDK, so if you're looking for some introductory material, you may be a bit disappointed. So I'm making the assumption that you're all familiar with what is SDK and when I say more, if I'm assuming that you're all familiar with what it is. And you know about me since you've been here for the past 2 sessions. I've been working with partners and helping partners in terms of integrating their solutions with vSphere platform and stuff like that. Been a regular speaker at VMworld and several VMware user group conferences and stuff. And okay, let's get to this. Now, you have a use case where you know what? I want to maintain an inventory. I want to keep track of all the hosts in my data center. Or maybe I want to monitor for changes to all the VMs. Whenever a VM power state changes, I want to know. Or I want to keep track of which VM is running on what host type of thing. So when you want to do any of these things, you just have to know how to use property collector. So property collector provides you ways to get the information and also to monitor the information, monitor for changes to any of the properties. When you are getting the information, if it is, how many of you are familiar with data object and managed object? Okay. So for people that are not familiar, I'm going to just give you a brief description of what is a data object. A data object is like a simple data structure. Like let's say if you create a student class with name, ID, and all that stuff, that is a data object because all the data is available on the client side as well. And the managed object is something that is represented on the server side. Like in a VC inventory, a VM is a server-side object, which is represented with managed object. All the entities that you see within vSphere client, those are all managed objects, which means those are all server-side objects. So when you invoke an API call, when you get the managed object, you are not getting any values. You are merely getting an index to that object within the database. Okay? So property collector gives you a means to get the data related to the data object, related to any of the managed entities like VMs or hosts or resource pools or anything like that. It also gives you avenues to monitor for changes to any of the properties that you are interested in. If you want to monitor for VM power state changes, you could do that. So in this session, let's go through. I'm trying to explain what actually property collector is and how it works and what are views and what is the relationship of views with respect to property collector, and how are views better in certain use cases, and why do you have to start using views more compared to any plain old property collector stuff. And I'll try to explain some use case scenarios in terms of why you should always start off looking at views when you are retrieving properties for more number of managed objects and stuff like that. And also, I'm going to explain what are some new cool features that are available in property collector in 4.1 and resources and all. And please feel to interrupt me if you have any questions and all that stuff. So, like I have been explaining, vCenter provides you a bunch of service objects like session manager, event manager, alarm manager, task manager, and property collector is one of those services. What is its prime objective? It gives you a way to get the information related to any of the managed entities within the VC. So in the analogy that I was explaining before, when you are asking your friend a favor, you need to explain what you want, and you need to explain how to get there. So the way you do that is using property filter spec. If you are writing a simple SQL query, you just write select star from this table where this and this. So it's as simple as that. In property collector terms, you explain that using property filter spec. If you know how to create property filter spec, you mastered property collector. So literally, property filter spec is all there is to it to understanding how property collector works. Okay, what is property collector? Okay, let's look at this use case where I want to get the names of all hosts within the inventory, the VC inventory. Could be across data centers, could be across clusters or anything. I want all hosts within my VC. So property filter spec has primarily two properties: property spec and object spec. Both of them are arrays. An object spec contains traversal spec. So in property spec, you tell it what you want. In other words, host name, you just want the name of the host. So you do that, you specify that in the property spec. All you want is name, the property is name, and the type of the object for which you want the name for is host system. That's all you do in property spec. And in object spec, you say, okay, I'm starting at this point. Let's say when you log into the VC, the only managed object that you have at that point is the root folder. We all know you start at root folder and then go through the inventory hierarchy in order to get to a point. So you specify, okay, if you already have the target managed object reference, you don't have to go through traversal spec. So we'll examine all those things in the coming slides. So in the object spec, you specify how you are going to. You're basically giving it directions. You're giving the property collector directions about how to get that information for you. And it may require traversal only if it is required. Let's say if you give it a root folder and you are trying to get the host system name, it has to go through the inventory hierarchy to go to the host system objects to get the data that you specified in the property spec for you. If you gave, instead of root folder, if you gave the host system object directly, it doesn't need to go through the traversal spec. Okay. So again, property filter spec, you specify what you care about in property spec. It's an array. So you could specify within one property filter spec, you can have any number of property filter specs, any number of property specs. Same thing holds good in the object spec as well. So when you start at root folder, you can, for each object spec, you can say, okay, whenever I have this, for within this filter spec, this is where I want to start. This is where I want to start. And in the traversal spec, you say, what is the path that the property collector needs to take in order to get to what I want, type of thing. So here is a simple code snippet where, again, the code snippets are in Java, but it doesn't matter whether you use C#. I would guarantee you, I would say, most of the times you could just do a simple copy. The only difference is maybe the object names or something like that, but the code is pretty much similar in C# as well. So in property spec, you have to think about, okay, if you ask a question, if property collector asks this question, what do I need to get you? You need to provide the answers for that. Which means here, you are interested in the name, so you kind of said that in the name. So you are not limited to specifying only one property. You can have any number. So this is an array of string. So this should match with the actual properties that you see in the reference guide. Okay? So you can have any number. Let's say in your case, for some special use case, you say, you know what, I need all the properties. I'm not just interested in one property. You can completely skip this and then see this set all to true. It will give you all that. So, but I want to remind you that there are very, 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 very few use cases where you needed to get all that information related to a specific object. And now, what type of object that I want to get that property for? So you say host system, because in the use case that we set out to when we started off this talk is we want to get the names of host systems within the inventory. All you do is you create a property spec, you are telling what you want, and you are telling the type of object for which you want to get the property. This is all there is to it for property spec. And property spec is one part of creating property filter spec. Okay, now let's go to object spec, because property filter spec is a combination of property spec and object spec, right? In object spec, property collector has two questions for you. One is, okay, where do I start? You asked me to get all this data. Okay, fine, I can get you. But tell me where do I start? So then you tell it, okay, I have a root folder because I just logged in, so I got the root folder. I don't have anything, so I needed to get some stuff. So I'm starting at root folder. So I'll give you a root folder. And then set, skip, and all that stuff. We'll look into what those mean in the coming slides. So you tell this starting point, and then it asks you, okay, you gave me the starting point, and you tell me the exact path I need to take in order to get the data that you're looking for. Then that's when you create this traversal spec. So in the coming slides, we'll show you how to create the traversal spec. So if you think about, let's say, imagine you have all the managed object references. You don't even have to worry about this. So when you are trying to retrieve the properties, this is all you need to do. You just, instead of root folder, you specify whatever morph that you have here. Property spec, object spec, that's it. Traversal spec come into picture only when you don't know the morph of the object for which you are trying to get the properties for. Simple so far, right? So any questions, feel free to ask me, because I want you to understand how this works. When you go out of this room, you say, you know what, I could use property collector however I want type of thing. So I want you to get that feeling. So please ask me questions if you have any. Yeah.
Properties, but is there a reference or some kind of document that tells us all the different properties we can return and the different types there are in the system?
Yeah. The question is, in the property spec, you mentioned that you need to specify these properties and the type of object and all that stuff. Is there a place where I can get all that information? Yes. Our reference guide contains all this information. So let's say if you go to the reference guide, the simple searchable field is there. Click on all types and then specify, let's say, if you are looking for properties of host system, type in host system, it will bring up the host system, and it's a table of all the properties that are available and the types of those properties. So in this case, name, and if you want more, like
Is there a way to get it automatically?
the properties information? No, it's all static information. It's already there in the.
I think in that metadata.
Create a dynamic UI that shows everything about the system. So instead of hard-coding all those names, like you're saying, I would like to automatically get them.
You could do set all to true. You could get everything. But again, you have to be careful when you're trying to get all of, because when you're getting lots and lots of data, it's the initialization time might be a bit more. So you need to be vigilant of what you're doing. So I mean, just for the sake of just set it to true, let's say out of 100 properties, if you are just using only one or two, it doesn't make sense to do that stuff because you're going to create a lot of overhead on the server. Yeah.
I think I understand what else he was asking. Is there a way, let's say, like in your GUI, you say, I want to look at hosts, and then a way to break back and say, okay, for the host system, what properties are for this type? And bring it all back and display a list to the user saying, hey, this is what the properties are for this particular object. Is there a function that would do that?
No. The question is there an API call to get the metadata, to get the list of properties that are available for a specific type of object? No. All the data is, I mean, you could write something based off of a reference doc and get that stuff. I mean, there is no API in vSphere per se to do that. There you go. So when we publish the WSDL gives you the reference. In fact, yeah, the reference doc also is generated off of whatever WSDL base is. So when you look at the WSDL, you can actually, so just like either look at the reference doc or look at the WSDL and then you could generate that stuff.
The only problem there is when you build your application and you build it for like 4.1, and then 4.2 comes out and you add some new properties. And since you're grabbing like a static list, it's not going to capture those new properties. So if we had a dynamic way of determining the properties, it'd be better
See,
for future compatibility.
4.2 comes with a new WSDL. So when you're starting to use 4.2 features, you needed to consume the new WSDL and generate your new stubs, and you need to recompile all that stuff anyway. So at that point, you could create all those things. The metadata function, you could actually capture the latest properties from that WSDL and then do.
But the problem is there has to be some kind of backward compatibility because each time you publish a new WSDL and I'm writing this commercial application, I have to tell my customers, hey, go take the new one, you don't use the existing application.
Okay, let me answer that question. It is not required for you to recompile every time a new WSDL is, unless you intend to use the new features. So let's say you created an application with 3.5 WSDL, you're fine. As long as you go to VC, your 3.5 application will work on 4.1, 4.0, 3.5, anything is fine. Let's say you want to use the 4.1 features, like 4.0 features like VApp. Unless you create new stubs that are aware of that new feature, there's no way you're going to use that stuff. So if your customer is content with the existing features and if he can you can just use that with the latest version of VC as well. So there is no reason for you or for your clients to recompile or redo any of that stuff. Okay? So, yeah.
If you are writing code for the 4.1, say you're retrieving a property that was introduced in 4.1, then you have to be careful if you run your code.
Can you speak in the microphone, please? I'm sorry.
I was saying, suppose you are writing code for 4.1 and you would like to write code that is backward compatible, but you also want to get some of the property that are in 4.1. Then you need to be careful and make some kind of if statement there, right? Because if you are running it against a 4.0 and you are asking for a property that is not in 4.0, it's going to barf, I think.
No, that's not it. As long as you are going to VC 4.1, you're fine.
Okay, suppose you're going to 4.0 because some of your customers still have 4.0 and they would like to run it.
Yeah, then
you need
you'll
to
have
be
an
aware
issue.
of it, right?
Because your stubs, whatever stubs that you generated from the WSDL, they have to match with the VC server. So if you generated your stubs with 4.1, you can't expect those things to work with 2.0 because the kind of object that you send, the SOAP message that you're sending to the server is going to be radically different than what it knows. So as long as you use that version, you're fine. Okay, yeah.
Still meaning of an array of object specs. I mean, understanding the beginning of the traversal. So why do you want to have more than one?
Okay. Let's say you want properties of two different types of managed objects. You want both managed objects available for you, no traversals. You could create one property filter spec, one with, let's say you have a VM and a host system. You have the MOREFs already. You can create one object spec with VM MOREF, another object spec with host MOREF, then put it in that array and then create in that property filter spec. One retrieve properties call will give you both. Okay. Yeah.
I actually just want to comment on what she said. The experience we have between 4.0 and 2.5 is you can request any property you want, and if vSphere doesn't have it, or it just returns a null value or returns an empty set. So you can actually make your decision after the fact instead of up front.
Yeah. Yeah.
I think what they're talking about, there's two situations. One is, the property selector is available as well version. So if you query property that isn't there, it'll probably just return null, right?
Yep.
But meanwhile, if you call a method that isn't in the newer version, then there would be like an exception or something.
Yeah, and also let's say if you in your property collector in your property spec, if you included some property that the server does not know about, you run into some exception conditions. That's what when I was referring to when I say whatever your stubs are, they should match with the server that you're running against. If you are at stub 4.0 version, if your stubs are at 4.0, make sure that you don't go to 2.5 using the same thing. Because the XML message that you are sending may contain properties that 2.5 server has no clue about. Yep. Yep. Yeah. Yep. Because it's 4.1 is a superset of 4.0, so you'll never have any issues with that. Okay. Now, when I go through this traversal spec, because traversal spec is the most important thing within the property collector object spec, because property spec, object spec are incredibly simple. Traversal spec is the only thing because what you're doing here is you are giving directions. If you are giving directions to a human, you can say, hey, go to this website, you can find that stuff. But computers are dumb things, so you have to tell it explicitly what you want it to do. So in this case, you have to explicitly tell property collector what you want to do. Okay, as I said, traversal spec name is pretty intuitive. Traversal means you're going from one location to another. So here is a simple inventory looks like. This is actually our lab setup, where this is the VC. Every VC has a top-level object called root folder, which is not visible in this. So I created a root folder child, and then RF child, and then data center, just to show you that there could be folders nested within root folder, and you could have data centers either as a children of root folders or children of root folders directly. So they could be nested like this, or they could be at this level. The reason why I put up this chart is this is important when you are trying to create traversal specs, because in traversal spec you need to understand there could be nested folders, there could be nested objects, because you need to take care of traversing through those nests in order to get to the destination object. Okay, now the simple case that we wanted to look at is we want the names of all host systems. So we specified all that stuff in property spec saying that name host system. And in the object set we said start from root folder. And we said this is the traversal spec. And now let's examine how this traversal spec works. So first thing is, I should have made it animated so that I get one at a time, but anyway, I'll explain this in this manner. First thing is, you have to, whenever you, root folder is an object of type folder. Any folder object has a property called child entity. And that child entity could be another folder. And that child, the folder is of type managed entity. So generically, folder object is of type managed entity. So this folder could be another folder, like you have seen in here, could be another folder, or it could be a data center. So when you start from root folder, you have to tell it, okay, you have to give it a name. Typically, you give traversal spec a name so that you want to reuse that later. So this is the name that we gave folder to child. And then what we are saying is, whenever you see an object of type folder, just simply go to child entity. So in traversal spec, it's saying from point A to point P, there are intermediary points in between, right? So when you go to point B, just do this. That's what we're trying to say. Whenever you see an object of type folder, just go to its child entity. Set skip is true. Okay, what is the meaning of it? We said in property spec, all we are interested in is host system object. So this is a folder object. We don't really care about its properties. So there is no reason to look into those properties. We simply say, just skip it. Okay. Now we know that when we go to a folder, we know that the folders could be nested. So every time we look at a folder, we want to just go through the same traversal, right? So selection spec, this object is a superclass of traversal spec. All it does is it will have a name which references to the already created traversal spec. This is a way of saying that, okay, when you see this folder spec, the selection spec, when you refer it by its name, you are telling it, okay, whenever I see this name, this is the traversal spec that I need to apply, because remember, this name matches with the name that we have here. I know it's a crude way, but for whatever reasons, that's how it's made. So you create this traversal spec. So all you did is, whenever you hit a folder, just simply go to its child entity. So we created this selection spec. I'll show you why we needed this, because in the previous slide, we know that the folders could be nested. So we need to account for that. So whenever we see a folder, we need to skip this. We need to go to its child entity recursively so that we can hit that. So now we have come to this data center. We went through the folder, and we come to this data center, or either one of those data centers. So we looked at all the folders, and we came to the data center. Now, data center, yeah. Okay. Selection spec is really a superclass of traversal spec. It's a simple way of referencing, okay, instead of creating another traversal spec, we'll say, when I create this traversal spec, when I have this name, you're basically saying, okay, that is the traversal spec that I meant when I say this selection spec. I know the name is kind of confusing, and I can't explain why the naming is like that, but I know the name is kind of confusing. But I'm going to explain you. When you say selection spec, what you are saying is refer to that traversal spec that you are referring with it. Oh, sorry. So now, whenever you come to the data center has a lot of children. One of them is host folder, VM folder, and all those things. In a moment, I'll show you the inventory hierarchy and all that stuff. So you've come to the data center. So you have to provide some direction to the property collector. Okay. Whenever you come to the data center, you simply go to its host folder, because all we are interested in is host system name. That's what we want. So if you were looking for VM names instead of host folder, you would be asking it to go to the VM folder. So from data center, you want to go to, so we set the skip to true because we don't care about data center properties. We're not interested in data center properties. Whenever property collector sees data center, it simply has to go to the host folder, look for host folder, and then just go there. And I select this select set to FTC array, and if you look at this FTC array, that is pointing to this selection spec, which is pointing this traversal spec. Okay, I'll show you this becomes pretty evident when you look at the inventory hierarchy slide. Data center can have folders, and one of those folders could be host folder, VM folder, network folder, data store folder. So you could have you could have folders, and one of those folders could be a host folder. So when you say at the data center level, let's say I have not created any folders here. Here I've created these folders, right? So if my host folder is in one of these nested folders, I just have to go through those things as well. So what we are saying here is, what we are saying here is when we set the select set to this, what we are saying is once you get to the data center, go to the host folder. But if you see any folder in the data center instead of host folder, just keep going to its child entity. At some point, you hit that host folder. So now you have come to the host folder. Now, host folder contains a property called compute resource. And compute resource is the one which contains the actual host object. So if you look at the reference guide, it becomes pretty evident. So what you're saying is, what you're creating in this traversal spec is, whenever you see compute resource object, simply go to its host property. And the reason why you set skip to true is you're not interested in compute resource properties. You're interested in the properties of the host. Once you get to the host, you don't have to traverse anymore because you are already at the object for which you are trying to get the properties for. So all we do is we combine all this thing into one big traversal spec. See here, when you create this selection spec, folders as spec is this one. So say, whenever you see, you are creating this big traversal spec here, big selection spec here, what you're saying is, whenever you see a folder type, go to its child entity, and whenever you see data center, go to its host folder. Whenever you see compute resource, go to host. So at this point, you have given enough directions for the property collector to go from root all the way to the host. Yeah.
I think the DT2, HF, and TR2 host both are traversal specs, and only the first one is selection spec. Why can't you just folder to child?
For what?
For the first parameter.
This one?
No, one below. That one?
That one? Okay, I'm creating a selection spec array here. So this has to be, so this could be, folder spec is this because when I see this, so okay, I needed to explain one more thing here. When I have this folder to child and I create this folder spec, what it is doing is it can provide you recursion as well. So in your select spec, what you're saying is, okay, this is the traversal spec. When you look at this traversal spec by itself, it just goes to this child entity and after that it doesn't know what to do. Okay? And when you create this selection spec, in the selection spec you are saying, whenever you see the object of that type, apply this. Okay, that is the reason why you create this. I mean, you could have done this right here, but the only way that you could refer to another traversal spec is you needed to create another selection spec anyway. So each look at this, traversal spec has all these properties plus your select set, which is nothing but you are referring to another traversal spec here. So it's kind of, you're like, you have individual directions, point A to point B to point C to point D. In between, when you go to point B, if you have nested B's at B, this is what you need to do. That's what you do here. So that's the reason. Yeah.
Do we need to specify the selection specs in that order?
No, it doesn't matter. Order doesn't matter. All it cares about is directions. And this thing is important too. At different types of the objects, if the object contains properties or another object that's going to be nested, if you don't set this here, then you are not telling property collector that data center might have this and then you need to traverse that path. So as long as you have your traversals right, this order doesn't matter. You can put it in whatever order, so it's going to figure it out. So once you go to the host folder, you go to the compute resource, and once you go to the compute resource, it goes to the host. Once it goes to the host, the way traversal spec is applied, traversal spec application, how traversal spec works is, property collector goes to, it looks at all that stuff. Okay, from folder I go to the child entity. I'm at the child entity. Let me take a look. What is the object type? Okay, the object type is something. Let's say if the object type is data center. Let me see, for that object type, my skip property is set to true or false. It's set to true, I don't care. Set to false, by default it's false, by the way. So if set to false, let me check in property spec if he wants any properties for this object. Let's say if you didn't set this, if you set it to false, and in your property spec you said name, and instead of host system you said, or besides host system you say name and data center as well, it could have given you the data center name as well, because when it comes to this point it says skip is false, let me check in the property spec array. In the property spec array, do I see an object of type data center? Yeah, I see it. So if I see, what is the property that he is interested in? Pick that up, pick that property, then go with it. I mean, even if you don't set the skip to true, it's not going to return you the property, but you are forcing property collector to that additional check. So you can skip that completely. Okay, so these are all kind of whatever I've been explaining within those things, like you are telling from one place to another place, and whatever the object that you start off with, and how to traverse on all that spec. So you could read these things at your leisure time. Okay, so if you understand how to write traversal spec, you are a master property collector, and I'm telling you, you will be the guru of vSphere Web Services SDK, be it in any programming language. So please try to understand, and then if you have any questions, feel free to ask me. If you can actually literally see when you write this, you tinker with this traversal spec, apply this concept, tinker with the traversal spec, and then figure out how things work. And you can actually enable HTTP and look at TCP-MON and actually see the SOAP messages and all, how these things happen and stuff like that. Okay. Now I know I'm ready to create traversal spec. I need to understand how on earth I'm going to go from root folder to the host system, which means root folder. I need to understand what are the children of root folder, what are the children of data center, what are the children of host system, and stuff like that. So vSphere platform has an inventory hierarchy that we publish every time, and it doesn't change that often. The only time that change happened in the past 4 years is when we introduced this vApps concept. And it didn't break any of the existing stuff, it's just that we added some more stuff to it. So I'll show you. And by the way, the inventory hierarchy is pretty much the same for both VC or the host system, with the exception of some things being singleton in host system by virtue of host being a single host. I'll show you what those are in this. See here, when you look at the inventory hierarchy, see, look at this. This folder could be root folder, which can contain another folder. When you see the star, that means that those objects could be nested. So you have a folder, it will have nested folders, and then you come to the data center. So that's why in our traversal spec, when we say whenever you see folder, just simply go to its child entity. It could be another folder or data center. So when we come to the data center, we say, when we are interested in host folder, this is here. So it could be nested in another folder, or it could be just a folder. So from data center, we come to this folder. So from this folder, we are interested in host system, right? So we said, whenever you see host folder, go to compute resource. And in the compute resource, we say there is no nested, so we can directly go to the host system. So that's why in our traversal spec, there was nothing in there in terms of another selection spec. So we come to the host system. So host system, when we see that, it matches with our property spec, as simple as that. So if you want to do the same thing for, let's say, network, all you need to see in host system, it's kind of a semi-difficult one, because you have go to data center and then go to compute resource and then go to host system. So potentially you have 3 different hops with nesting. Whereas if you're going to network directly, it's just 1, 2 hops. And if you're going to the data store, it's simple, just 1 hop type of thing. So you could actually play around with those kind of things and then learn how this thing works. And the same thing for ESX. The only difference in ESX is only resource pool and virtual apps are there could be nested things. Well, and its host system is going to be 1, and there's going to be 1 data center and stuff like that. Okay. So any questions so far on traversal spec or anything? Yeah. So the question is, okay, with 4.0 we introduced vApp, so you added something to the inventory. So if I had created an old traversal spec where I was just stopping at VM folder, would it give me all the information that is there within the vApp as well? Well, not, because you are not traversing that part of the path. So that's a great question. And I have a solution for why you can immune your code to all these inventory changes when we talk about views. Because views provide you a great simplification when you are looking at larger number of objects or even more than 2 or 3 objects. I'll show you code snippets and all this stuff, why those are the most efficient and simple to use. Because, okay, now putting it all together, all we needed is created this property specs and then object spec, and then once you have this, set the property spec, object spec, done. So once you get the retrieve properties, you get the updates, you get the object set, then you're done. This is all there is to it for using property collector. So any questions? Okay. Another thing is, you might think that, oh, do I need to use property collector for everything? Yes and no, in a sense. you needed to create traversal specs. I would say about 80 to 90% of your use cases can be satisfied without having to write a single line of traversal spec. I'm not joking when I say that. The reason is, let's say I'll give you some simple example. You want to just get the MORF of a VM. You don't know anything but its name and the data center in which it is residing on. You could use search index where find by path, just pass in the data center name and VM, data center VM name, you construct that in a specific thing, and then it will give you the MORF of the VM directly. Once you have the MORF, no traversal spec because you're interested in the properties of that. Another great way, create views. But when you're creating views, you still need to use property collector in order to get the MORF for the object for which you are trying to create the view for. We'll get into all those details. Okay, what are views? Views allow you to create some sort of containment with a group of managed objects. Could be group of VMs, group of hosts, or group of folders, or anything like that. So once you created that group, no traversal, because instead of at VM folder, you created that group with a view at some other place. So no traversal. Because you asked VC to create that, when you asked VC to create a view, you're asking VC to, create a view with all these objects within that view, then you don't have to worry about traversal. The view, when you go to the view has all those objects for you. And when we get into the details of types of views, I'll show you the code snippet of how exactly you can do all those things. These are by far the most efficient, views are the most efficient, provide the most efficient way in order to get the data or monitor the data when you're doing multiple objects. And a traversal spec, I'm going to tell you the 5 lines of code that I have for the traversal spec for the views. No matter what type of view you create, it is going to be exactly the same. You can even copy paste the code that you see here and reuse everywhere. It doesn't matter what type of view that you have. Okay, there are 3 types of views: inventory view, container view, and list view. I'm going to come from bottom up so that you can get a better understanding. So list view is, for example, you want to create a view out of 10 VMs of all the VMs within your inventory. 5 VMs from production data center and 5 VMs from QA data center or whatever it is. So you get the MORFs of all those 10 objects and you create a list view. So what you're doing is you get a bunch of MORFs for a bunch of objects and you're asking VC to, here are the objects, create a view for me. So from now onwards, whenever I ask for properties for any objects within that view, just get me from that view. And when you are monitoring, these are extremely useful when you are writing monitoring applications. The reason why I say that is, let's say you want to monitor for power state changes of certain VMs. In your data center, let's say, in your data center, let's say you have database VMs, SQL Server VMs, and probably web server VMs and some middleware VMs or something like that. You wanted to monitor for power state changes to only a group of those. You could create a list view and then monitor for those changes. And later, let's say I want to add 2 more VMs to that view. I want to monitor 2 more VMs. You can simply add them to the view. Things are going to be automatically done for you. So list view, in essence, what list view does is you have to get the MORFs of a group of objects, then you create the list view. Container view, it happens at the container. You get the MORF of the container, like a data center or a host system or a resource pool, and then whatever objects that are there within that container, those are going to be within that view. And you can specify the type of objects. So when we look at the code snippet, it becomes clearly evident how you can do it. An inventory view is a superset of container view. For example, inventory view covers the entire inventory. You can turn on and off whatever containers that you're interested in or whatever folders that you're interested in. Let's say in the inventory that I showed, I have 3 data centers. If you are interested in only one of those data centers, production, QA, dev, so only production, you could create an inventory view and then you can only open production. You want to add QA as well, you can say open QA as well. If you don't want QA, just close that stuff. So that is the flexibility. Whereas you could do the same thing with container view as well, but with container view, you have to create and destroy views whenever you don't want a specific data center. Whereas with inventory, you create inventory view once, you can open and close the containers within that inventory view. That's called open folders and stuff like that. Open folders, close folders. Okay. I'm going to give you an example of this container view. All you need to do is get the more of the container. For example, you know what? I want to get the names of all host systems and virtual machines within my VC, not even one data center, all data centers. You could create a container view at the root folder because you already have the Morav at the root folder. That is the container Morav. And then when you are creating a container view, you are saying view manager is another service object, just like property collector that VC provides. Container Morav, this could be the Morav of, let's say, whatever data center that you want to, or in this case, we could just simply use root folder. And then you are saying, please include host system and virtual machine objects in that. And what does that recurse means? Like if you have any objects of this type nested in those, just include all those things as well. So once you create this container view, your property spec doesn't change. It doesn't change because all you are saying in your property spec is this is what I'm interested in. So you're telling, just get me that. And the traversal spec, this is literally these 5 lines. That's all you need to do. No matter what type of view, no matter how and when you create that stuff. You can literally copy paste these 5 lines in your code. Because every view object has a property called view, and the type is the one that you specify the different type, like container view is container view, inventory view is inventory view, and stuff like that. And in the object spec, you are starting at the container. You're not at the root folder or any other stuff. And then whatever the traversal spec is. As simple as this. All you need to do is, if you are trying to get the name of all hosts, just in this, don't specify this virtual main, just the host system. And then here, for container Morav, specify the root folder. Now you got everything. Like in the first case, when we started off this talk, I said, I want to look at all the names of the host systems within my VC. If you had to go through property collector without using views, you needed to specify that complete traversal spec. Whereas if you were going through views, all you needed to do is just create instead of Morav, the container Morav is the root folder. You could specify, I want only that data center. In that case, that's when you understanding the property collector, creating traversal spec comes in handy because you still needed to get the Morav of that container, like a specific data center that you are looking for. So once you have it, boom. Once you have it, this is pretty much the same. You can actually copy paste the same thing and maybe change some of this. Only the arguments may change, that's all. So once you have this, you have pretty much everything. So once you create this, you can use this to retrieve properties, or you can use this to monitor properties or any of that stuff. I want to explain one more thing before getting into these use case scenarios. When you use property collector, when you retrieve properties, wait for updates, there are 2 different types of calls, right? When you do retrieve properties, what property collector does underneath is, it's going to create all the filters, property filters for you temporarily. Get that information following the spec that you specified. And then sends you the information back, destroys all those filters. When you do a wait for updates, in wait for updates, you are explicitly creating filters because you want those filters to persist during the length of your session. So you create filters first and then wait for changes to any of the properties that you specified in that filter. So that's something that I wanted to, I missed to put it in. Okay, the use case scenarios. Now, if I want to retrieve the names of all VMs and host systems in my inventory, you have 2 options. One is you could use views, or you could say, you know what, I know traversal spec, I don't have to use views. Yeah, you could, because now you are the master of complete property spec. You have two things at your disposal. But there are some advantages with using views. One is it's going to keep track of any changes that's going to happen. For example, if you, like that gentleman pointed out, from 3.5 to 4.0, we introduced this new concept of VApps. So we added some more things within the inventory hierarchy. If you were using views, VC would take care of including those objects in that view. You don't have to worry about that extra hop of the traversal spec. If you were not using views, now you needed to include that traversal spec in your application. So which means your code change and then blah, blah, blah. So you have to go through QA cycle and all that stuff. So that is one of the that is why I'm suggesting big time, go for views. But it doesn't make sense. Let's say you have a specific VM and all you want to do is just get its guest name or IP address or whatever it is, just one VM. It doesn't make sense to use views in that. So remember that one size doesn't fit all. So if your use case involves getting properties from multiple objects, I definitely go with views instead of plain old stuff. But please try to understand how to create traversal specs. Yeah.
But if my use case involves, let's say, getting everything that you have in your VI client and getting those updated, you would recommend using views instead of, let's say, using the regular property collector way of doing it.
Yeah. The question is, if I have to get all the properties that are related to all the VMs or hosts within the inventory, and I want to keep track of changes to that, would you recommend using views? Yes, I do. Because views, there are a ton of benefits with views. They are the most simplistic way to get the information, plus you are kind of immune to any inventory hierarchy changes because you are using views. The onus is on the VC to keep that view up to date. So you don't have to worry about that stuff. Plus, when you are monitoring for changes, you'll end up creating filters. With view, you create only one filter. Whereas if you are selectively using things, if you are selectively monitoring for changes to a certain number of VMs, you'll end up creating those many number of filters. So that is my actually second use case. So if I want to monitor the power state of several VMs across different data stores, you have two choices. One is when you use the property filter, since you want to selectively pick and choose VMs, you could create property filters for each and every one of those VMs, and then use wait for updates to do whatever monitoring that you could do. Or you could create a list view, just get all the models of all those VMs, create a list view, and be done with it. If you decide not to monitor some of those VMs, simply get those VMs out of the view. That's all. You don't need to recreate the filter, or you don't need to do anything. If you want to add more, just simply add that to that. Yeah.
So looking at this, a view can be pretty big, right? Because I can define view like the inventory view to be pretty big.
Yep.
And if I want to load the whole view, it might really exercise the HTTP layer really well. So is there a way where I can say, yeah, my view is big, but just give me page 1, page 2, page 3 kind of thing?
Excellent question. We have those provisions in 4.1 property collector updates, property collector improvements. So I'm going to go through when I explain you what's new in 4.1. Yeah. The question is, if I create a big container view, and if I'm looking for like 10 properties of all those elements, all those objects within that view, if my return data set is huge, am I going to have any problems? Or do I have some sort of pagination mechanism provided by property collector? As of 4.0, there was no pagination, but in 4.1, that is there. So we'll go into those details when we go through the what's new and stuff. Yeah.
I would like to write an application, but not create the view. I would like my customer to create the view because I don't know how they want to use it. 10 machines, 15 machines. So I just want to create an application and let the customer create the view. Is that possible?
Yeah, it is. You have to provide reasonable interfaces for the customer to say. You can't ask them to code, right? So you can say, you can write a simple UI saying that just drag and drop here and then provide some button. You drag and drop and click that button. Behind the scenes, you could create a view and you just say, Let's say you're creating some sort of monitoring dashboard or something like that. Whatever VMs that you want to monitor for, just drag and drop those VMs, and then here are the properties that you want to monitor for, like power state or something like that. And then click off a button, boom, behind the scenes, go create the VM and do whatever magic that you wanted. Okay, what's new in 4.1? 4.1 gives you actually 3 significant changes related to property collector. The biggest one is pagination when you are trying to retrieve properties. And the new API is retrieve properties EX. And when your another change is when you are trying to wait for properties, you can actually set a timeout to gracefully timeout on. You don't have to wait for eternity and wait for property. So we'll get into all those details. But see, these are the new APIs: create property collector, destroy property collector, and all these things. So you might ask me, I mean, I've been getting this question over and over again for some time. Like, I created 10 filters. Why don't I have a way to map one-to-one, like one filter, one wait for updates? Because it puzzles me that my wait for updates contains everything, and I have to sift through all that stuff even though I have not created that filter in here. So now you have an answer for that. When you create a property collector, when you create a property filter, you have to associate that filter with a specific property collector. With this create property collector, you could create any number of property collectors you want. But again, as the number of property collectors that you create increase, you're going to putting that much load on VC. So this is the primary use of creating multiple property collectors is, let's say you have a use case where you want to wait for updates on properties of 2 different types of objects in multiple threads. You have to always remember that your number of threads should always be directly proportional to the number of property collectors. Otherwise, the kind of results that you are going to get are going to be skewed. I'll explain you later when we go into the details in the coming slides. But a general rule of thumb, one property collector, one thread waiting for updates. As long as you do that, you're fine. Yeah.
But that won't work, right? Because let's say I'm interested in a lot of, then I don't have so many threads. So the solution that we were thinking was, I'll just have one thread, and it will do wait for updates, and timeout is almost like now. So it'll just immediately return. So I'll get any changes from the last time I made a call, and I'll do it every 30 seconds. So, and then now I'll get like, let's say 50 things changed. I'll have my own queue to do the processing of that.
Sure, you could do that. This is for, like, there may be some use cases where you say, I don't want to, see, assume that you have 2 parts of an application, which is monitoring only the VMs, which is monitoring only the hosts. And you don't want your logic of acting upon that change to be skewed. Then in that case, you may have you have a use case where you can say, you know what, I don't care about, I want to create a filter related to all the VMs here. So I'm going to create a property collector here and associate this filter with this. So then I get changes only related to the VMs, or whatever filter that I created that I associated with it. So this, and the biggest benefit of creating multiple property collectors is you can have multiple threads. Always remember this, the rule of thumb is one property collector, one thread when you're doing wait for updates. Okay. Now, retrieve properties EX, this is where you can specify pagination, you can limit the size in the return data and stuff like that. And when it returns that, if it has more data, it's going to give you some token. You use that token and then get, let's say, you know what, I'm fine with the first page, I don't want, you can trash the rest of the stuff using cancel wait for updates and cancel retrieve properties API and stuff. Wait for updates, you can set the same thing. Whatever happens in the update set, just like in retrieve properties, you can set the page size there. In your update set, I don't want zillion pages, all I want is, okay, if you have updates related to 1,000 objects, you can say, give me page by page, with each page containing only 100. You can set that something like that. And also, you can set a timer. Let's say, I've seen in most of the cases where underlying socket will have, like if you use C#, you have a way to set unlimited socket timeout. But if you use Access, by default, the socket times out after 10 minutes. So if you didn't know that, if your wait for updates is waiting on a property that's going to change seldom, that's going to change very, once in a blue moon type of thing, then your socket would have timed out and you will be like, what's going on type of thing. So here, you can actually say, in this case, you could set the timeout so that your wait for timeout comes out before your socket timeout exception comes in. But if you have a use case, you still need to figure out whatever socket timeout that I need to extend, you need to extend and then do these things. So, but now you have a way to gracefully come out of this. And remember this, from 4.1, we're going to deprecate check for updates and wait for updates. We're asking you to use wait for updates CX because you can specify all those extra options of page size and wait timeout. The cancel check for we are going to not have this check for updates because in wait for updates you can set the timeout. If you set the timeout to 0, it's actually whatever check for updates does. It does whatever check for updates does. It immediately checks. Okay, so whenever a general rule of thumb, whenever you are monitoring for property changes, use the summary because summary encapsulates pretty much most of those things, and there is not a huge cost. The additional benefit when you do this will give you is summary encapsulates some other properties as well. Let's say in future if you wanted to, hey, I wanted to use that property. If it is already there in summary, you didn't have to do anything in your code. But if you're damn sure that you're not going to use any other stuff except for that one property, go for it. And the biggest benefit of multiple property collectors is multiple threads. And I'm almost done. And again, deprecations and wait for updates all the time. You need to use the version string, whatever version string that gets returned. So just use that in the next one. And another thing that I want to point out is don't have multiple threads trying to do wait for updates check thread on the same property collector. So that's going to give you disastrous results. And these are the tools, and there's resources and stuff like that. So if you have any questions, feel free to ask me. And that's it. Please fill out the surveys. And I hope this session was useful. This is the first time that I'm doing this session. I wanted to do this for some time.